Okay, let's do this problem here. A tower guide wire is anchored by means of a bolt at A. So this is the point A here. The tension in the wire is 2500 newtons. Let's put that here. 2500 newtons, 2500 newtons, tension on the wire. Determine A, the components of the force acting on the bolt and the angles defining the direction of the force. Okay, so they are asking for the force applied at the bolt at A. So the force will be a vector going up like here, something like this. So this is the force, let's call it T, 2500 newtons. In order to find the components of the force, we need to find either the angles or the cosine of the angles, because the components are no other than the magnitude of the force multiplied by those cosines. So the cosines, the angles that we are talking about here are the angles that the line AB makes with respect to the axis X, Y, and Z. So if we find those angles, those are the angles that we have to use as in order to get the components of the force. So in order to get those angles, we need to see what are the components of the line that goes from A to B. In order to go from A to B, so we need to move in the X direction, this amount here, 40 meters in this direction. That will be, let's call it dx. That's something like the X component of the line AB. That will be 40 and is in the direction opposite to the X positive. So it's going in the negative direction of the X axis. So it will be minus 40 meters. Minus 40 meters. Then in the Y direction, in order to go from A to B, we move up 80 meters. So we have to go like this in order to reach B. This is the Y component. This, let's call it dy. So that component of the motion from A to B is in the Y direction and it's going up, so it's going in the positive direction of the X axis. So this is 80 meters positive. And then we have the component in the Z direction for the line A to B. So in that Z component, we have to move like this. And then we reach point B. This little segment here will be DZ. So when you go from A to B, you have to move dx, dy, and dz, and those are the in other words, these are the rectangular components of the direction AB. So and in the C direction, the distance that move is 30 meters. So 30 meters. 30 meters. So if we have the components of the line AB, if we find the total length of the line AB, we can find the cosines of that direction. So AB, the distance from A to B will be equal to a square root of 40 square plus 80 square plus 30 square. So AB come out to be, let's see what we get here. From A to B we get 94.3398. 3398. Okay, so we have from here we can get very easily the cosines of the angles that the line AB make with respect to the axis X, Y, and Z, which are the same angles that the force makes because the force goes in the same direction as the line. So the cosine theta X will be the component in the X direction divided by the total magnitude, which is the hypotenuse, 3398. So this cosine comes to be minus 0.424. 4240. Now the cosine of theta y will be the y component of the distance between A and B divided by the total distance between A and B, 3398. So the cosine theta y will be 0.84800, 5 significant digits. The cosine of theta z will be the z component, 30 divided by 94.3398 equals to 0.31800. Alright, from here we can get the components fx, or tx, dy, tc by multiplying the magnitude of the force, 2500, by the cosine of the angle with respect to x, which is minus 0.424, equals to minus 1060 newtons. The component in the y direction will be the magnitude of the vector of the force multiplied by the cosine of theta y, 0.848, equals 2120 newtons, and the component in the z direction will be 2500 times 0.318 equals to 795 newtons. Alright, so those will be the components. The angles will be on no other than just getting the arc cosine of these values here. Theta x will be the arc cosine. Maybe you can say better cosine minus 1. Cosine minus 1 of minus 0.4240, which is 115 degrees. Theta y cosine minus 1 of 0.848, that will be 32 degrees, and theta z will be cosine minus 1 of 0.318 equals 75.5 degrees. This one here with three digits will be 32.0 degrees. And we can write the force T like in this Cartesian notation, 160 newtons I plus 2120 J plus 795 K. So those will be the components. All right, that's it. Okay, let's do this other problem here. A wall section of a precast concrete is temporarily held by the cables shown. Knowing that the tension is 840 in the... Alright, so in order to get the rectangular components of the forces, we need to find the cosines of the directions of those forces. Same as we did in the previous example. So let's start with AB. In order to find the rectangular components of the forces, so we can make the summation of the components in each direction, we need to find the cosines of the angles that these directions make with respect to the axis. So the first thing we need to do is to define some axis. Let's do here like x-axis in this direction here. Let's put y-axis and the vertical direction here, y-axis, and z-axis parallel to the wall. This will be the z-axis. That will be the z-axis. Okay, so let's start with the direction AB. In order to go from A to B, we call that component ABX. In order to go from A to B in the x direction, we have to move from here to here. That will be 16 feet. And it will be in the negative direction because we are going in reverse, in the opposite direction as the x positive axis. That will be this one right here. Then the component in the y direction to go from A to B will be going up here the height of the wall, which is 8 feet. 8 feet. And then we have to move in the z direction. And this 8 is positive because we are going up in the same direction of the y positive. And then the z direction will be this path over here on top of the wall up and we reach point B right here. So that distance is this distance right here, 11 feet. 11 feet. Oh, sorry, let's do the 11 feet here. BC will be 11 feet. So the distance from A to B, the total distance of the line, will be a square root of will be equal to the square root of 16 square plus 8 square plus 11 square. So the distance AB comes to be 21. So from here we can get that the cosines of the direction AB would be, let's call it theta ABX is equal to minus 16 over 21. The cosine theta ABY will be 8 over 21 and the cosine theta ABZ will be 11 over 21. We can leave it like that for now. So the decomposition of the tension AB will be component ABX will be 840 multiplied by minus 16 over 21. The component ABY will be 840 times 8 over 21, and the component C will be 840 times 11 over 21. Is the magnitude of the force multiplied by the cosine. So this comes to be minus 640 This comes to be 320. This comes to be 440. Okay, so we have to do the same for the other force. Let's do it. Let's do it right here. For the other force, then we have that. I think we don't have the graph on hand, so let's do something here. Let's move that to the other page. Okay, so let's do the same for the other force. That will be the line AC. So we have ACX. ACX will be the distance that we have to move in the x direction in order to go from A to C. That will be the same 16 feet. But we are going in the direction of the x negative, so this will be minus 16 feet. ACY will be the vertical height of the wall. That will be 8 feet. 8 feet positive, and then ACZ, that will be, so we have here 16, then we go up 8, and then we move back down there, will be 27 minus 11 here, so will be 26 will be 16, and it's going in the direction of the negative C, so this is negative also. So this is negative. So now we can find the total direction, the total distance from A to C as the square root of minus 16 square, same as 16 square, plus 8 square, plus 16 square. So AC comes to be 24. So now the components of the force TAC would be 1200. I'm gonna put it here in one whole line, multiplied by minus 16 over 24 I. Plus 1200 times 8 over 24 J plus 1200 times minus 16 over 24 K. So this comes to be, the AC comes to be minus 800 I plus 400 J minus 800 again K. And let me bring back here from the other page what we obtained for AB, which was minus 640 I plus 320 J plus 440 K. So now we make the summation of the components in the same directions, X, Y, and Z. We get the components of the resultant. So this will be the resultant will be equals to, I can put here this vector sign. The resultant will be minus 800 plus 640, 1440. So there will be minus 1440 I. This will be 720 J, and this will be 3 plus 360 K. Okay. So these are the components of the resultant. If we want the magnitude of the resultant will be 1440 square plus 720 square plus 360 square, the square root of all that. So that magnitude will come up to be 1650 pounds. Now, if we want to get the angle, which is the other question, of the resultant, theta x will be cosine minus 1 of 4. This is negative. This is very important. This is negative. Cosine minus 1 of minus 1440 over 1650, which give us 150.8, 151 degrees. Theta y will be cosine minus 1 of 720 over 1650, will give us 64.1 degrees, and theta z will be cosine minus 1 of 360, actually 360, this is negative. I made a mistake here. This is negative. This is minus 800 plus 440 is minus 360. So here we have to do minus 360 divided by 1650. That gives us theta c equals 103 degrees. So those are the answers, the angles, the three angles, and the magnitude and the components of the resultant, or the summation of those two forces. All it. Please review on your own these other two examples on the book, example 2.8 and 2.9. Please take a look at those in order to get a nice review of a couple of more exercises here. Please do it. Okay. Take care.